We're solving problem 14 from the fall AMC 12A from 2021. In the figure, equilateral hexagon ABCDEF has three non-adjacent acute interior angles that each measure 30 degrees. The enclosed area of the hexagon is 6 square root 3. What is the perimeter of the hexagon? So the problem says that, well, each of these interior angles have a measure of 30 degrees. But this is a very strange hexagon. It doesn't even look like a hexagon. It basically looks like a circle. But here you have that. So now it's just 4 triangles, 3 identical ones, and a smaller one. So we know that's 30. So here, let's see. What can we do here? Well, we have this angle. We know that's 30 degrees, and we have a lot more angle measurements. But let's just make it into a triangle, since that's what it looks like. We are given the area too, so it won't hurt to do something like this. Now, what we can do here is, let's let G be a point right there. We draw G such that it is a perpendicular bisector to this triangle. Now, basically, it says that the area is 6 root 3. So we can have an expression of the area here. So our area, 6 root 3, is equal to the whole area of triangle ACE. So, and then you subtract the 3 triangles, minus 3 times the triangles D, C, and E. Now, what does the problem want you to solve for? You want to solve for the perimeter of the hexagon, aka 6 of these identical side lengths. Now, to make for easy computation, let's let x equal the length of CB. So the perimeter is 6 times x. We want to find x in this scenario. Well, we do know that, well, we can solve for this angle C 90 degrees. We can also solve for that angle. So this ultimately means that this angle is 75. Now, what we can do here is simply, we know that CDG is 75 degrees, right? So we can set up an equation. So CG, that length, is equal to trigonometry. You can use it. X sine of 75 by using SOHCAHTOA definitions, where that is simply the opposite side divided by the hypotenuse is equal to that side. So we have that. And by trig definitions, this is simply the square root of 6 plus the square root of 2 over 4 times x. Now, the same thing occurs with dg. This is x times the cosine of 75. Since we're finding a different length, where this yields to be the square root of 6 minus the square root of 2 over 4 times x. Therefore, we can find the area of ACE. The area of ACE is equal to square root 3 over 4 times 2 times CG squared. And plugging these values in, this is root 3 over 4 times 2 plus the square root of 3 times x squared. So we have that. And, well, now, let's see what else we can do. This means that essentially ACE by simplifying the equation, is equal to 3 plus 2 root 3 over 4 times x squared. So the area of, let's say, DCE, one of the smaller triangles, is simply 1/2 times 2 of these triangles, which cancels out. So this is just CG times DG. We also know that DCE is equal to x squared over 4. Now, after so basically, when you plug these values in from the equations we have before these two equations, we simply get that DCE is x squared over 4. So now we have a big equation where we have our two areas we want to find. So if we use our first equation here, as we have both the values in terms of x of ACE and DCE, we get that 6 root 3 is equal to 3 plus 2 root 3 over 4x squared minus 3 squared over 4. This is all just simplifies down to 3. I should erase it. This all just simplifies down to root 3 over 2x squared. Solving for x by dividing both sides by 2 over the square root of 3, we get that x is equal to 2 root 3. And since we want 6 times the value of x, our answer is simply 12 root 3. And that is the solution for this problem.